Alright, welcome back here to Vacuum Tube Paradise, and we have here a Fisher 500C stereo multiplex receiver. Came in for restoration. Right, I've done at least 400 of these in the years I've been doing this, so this is a no-brainer. But I figured I'd do a video documentation, just go over it briefly. All I did so far is pull out 2 output tubes. Otherwise, it's untouched the way it was removed from its cabinet with the dirt, and there's a little bit of rust on the transformers, which is not a big deal. Just we'll clean it off and do whatever. It appears to have, at least from the tube side of it, like it was probably never touched. They look like they're all original tubes, all the original German Telefunken 12AX7s. It appears the tuner tubes are all original. And take note of these 500Cs. You see these 2 small metal things. These are vacuum tubes. People don't realize it. These are small little tubes right next to the RF tube, which is glass. Those are too small. The early 500Cs don't have that. They have glass tubes. This is a 6HR6, which for some stupid reason is a pain in the neck to get, but you could use a 6AU6 in there really, and it just about makes no difference. This is supposed to be a little bit more sensitive. It saved them the trouble of an additional IF stage, but in actuality, like I said, it hardly makes a difference. And it's got 9 12AX7s. This is the multiplex board. This does the stereo decoding. It's a separate sub-chassis. Fisher was very smart in that regard, as is the front end. The whole front end is a separate sub-chassis. You can see the mounting screws right here and over here. This, you can actually remove this whole thing. Space expander jacks in the back. Output tubes, like I said, 2 of them I pulled out. Looks like the original dirt. Chassis is in good shape. It's a late serial number. Looks like 79 and change. Very good. The later ones are really nice. Not that the early ones aren't nice, but just like I said, they're just maybe a little bit more sensitive in the tuner, maybe not. Depends on the unit. Anyway, we're gonna take the bottom off and take a look at the guts of this thing. Okay, so we have the bottom removed, and it appears the only work that was done was the bias rectifier was changed right over here. Let's see if we can get a little more light in there. There we go. Yeah, you can see that down in here. It's got a regular silicone rectifier. So, it was done a little, not too sloppy, a little sloppy. We're going to change that. This is the original bias capacitor. We're going to change that. That's going to go bye-bye. So this whole area is going to get completely rebuilt. We're going to double the capacitance. This is 1,000 microfarads times 2. We're going to put 2,200 microfarads times 2, give it a little extra filtering capacity. These are found in some 500Cs. These are, this one doesn't even look like it's attached. Oh, somebody, look at this. This is cut off or broken off. Whatever. Yeah, we're going to change those. Those are the originals. They're like ceramic. See those on the later ones. We're going to put cathode resistors on the output tubes. And all of these old capacitors are going to get changed. Everything's going to be like new. We're going to strip this thing down, pull the face panel off. We're going to pull all the knobs off. We're going to restore the knobs, clean the glass, new foam rubber behind the face panel, etc., etc. This cover comes off. We're going to clean in there. Don't ever take this off unless you know what the hell you're doing. These things are no joke. And when everything is done, we check it, see what filter capacitors are like. If we need any, if anything is even a little bit marginal, we're going to change them. And then we do the alignments, the tuner alignments. This is going to get changed. These always get stressed out. You can see it's a little bit dark on the ends. It's a 7-watt resistor. We'll put a 10-watter in there. This is the what do you call it? The not the micro tune, the stereo beacon relay. That actually turns the little stereo beacon light on and off when it detects stereo. And this is the bottom of the multiplex board. All this has to be changed. Not, I mean, all of it. These capacitors, this one. There's 2 of them over here. I have to go. These 2 little guys. These are capsules that contain the diode matrix. It looks like a little diode bridge. There's two of them, one for each channel. You see that on the schematic, crystal clear. And that's about it. We're going to vacuum all this dirt out. There's a lot of dirt in there. This is the volume control. We're going to check that, make sure that's good when well balanced. If it has issues, we're going to put a new one in. And that's about it for right now. Now it's time to work. As we get into the restoration of this, what we like to do, what I like to do, is to strip this thing down to nothing, pull everything out, all the tubes, shields, covers, anything you could pull off. Get those little 6CW4 tubes out of there. See, those are the sockets where those little metal tubes were. I'm going to pull out those space expander jacks too. We're going to clean them. I like taking the face panel off. This way I won't have any chances of scratching it. Now these knobs sometimes pull right off, and sometimes they get a little stubborn, in which case you use one of these things, one of these little rubber grips, and you just pull off all the knobs like so. This space and treble is a double knob. As you can see, there's two knobs because that's a dual control. As is this one. I don't think I need the rubber for that. Oh, maybe I do. It's kind of stuck. See, this one's really stuck. I'm going to pause this a second. Okay, yeah, that one was like really stuck. I actually wrapped a double layer of that rubber and very gently grabbed it with a pair of pliers and yanked on it. And unless you got a spare knob, I don't recommend that. What I do, if that is really that stubborn, normally is I hit it with a heat gun. You just put a little piece of cardboard to protect behind the face panel and blow down onto the knob with a heat gun, and that normally breaks it loose. This panel is held on with these hex nuts. And I'm going to take off, there's one here, one end, and one here on the other end. So I'm going to take those off. I'll show you what's behind there. Yeah, the screws were so loose, it was just about falling off. So I'm going to take off the face panel. Here's the back of the face panel. These were made by Loveco Metal Finishers in Long Island City, where they built these receivers. There's the face with the panel removed. You notice there's this foam rubber here. It's all rotted. Touch it, it's just going to crumble. It's going to be all pulled off, all this foam rubber, and we're going to replace it with foam rubber, but we're going to mount the rubber behind the face panel instead of on the glass. So anyway, we're going to leave this like this while we continue with the restoration of the circuit, changing the capacitors and doing our rebuild, and then we'll get back to cleaning this thing and pulling the glass and changing the dial lamps and all the other good stuff. Okay, so here we have the stripped down chassis. You pull everything out, all the tubes. Obviously, we already checked all the tubes. I checked all the tubes. It's a remarkable set. Most of them were good. The cover is off the speaker selector so we can clean it and inspect it. The bulbs are out. Everything is out. Everything is stripped out. We have to get the dial glass out. I'm going to give a nice light cleaning to this chassis. These transformers have a little bit of light rust on them. I think we could clean most of that off and get this dirt off. The only thing you use on these chassis is either ammonia or Gugon. Those are the only two things that I have used for years and years, and it's never ever damaged the writing or anything else for that matter. Of course, you don't want to get any of this stuff on the dial glass. The dial glass is to see nothing but a damp paper towel. No soaps, no alcohols. These people use all this crazy stuff. I don't know what they think they're trying to remove, but these dial glasses are fragile. Nothing but a damp paper towel, which we'll go over later on when I pop this out. The glass comes out. These screws here have a clamp underneath this rotted foam rubber. This foam is like a rock, and some of it is just so bad it just crumbles. All this stuff, all going to be, so we're not going to replace it on the glass. We're going to replace it on the face panel, which I'll show you later. It's really better if it's on the face panel and not on the glass. And I'll show you what we use for that. We use a weather stripping. Here's the other 2 mounting screws. Here's the dial lamps. I'm going to put 2 brand new ones in, even though these look good. I'm going to pop them out, put 2 brand new ones in. When you're removing the glass, you remove these clamps. The glass is not going to come out. There's a rubber underneath here, and it's stuck to the rubber on both sides. So what you need to do in a case like that is you need to get a popsicle stick, like this, popsicle stick. And you stick the popsicle stick under the end, like this, after you remove the clamps, of course, and you pry it, and the glass will pop right off. It's a little nerve-wracking, but it'll pop. Once one side pops off, the other one comes right out. And then you can reseat the rubbers. The rubber has an adhesive on one side that usually is still good. You just stick it back to the panel. Clean the panel. We're going to clean behind here. We're going to clean the dial pointer, which is filthy. Believe it or not, you wipe that. It gets brilliant white. And clean the whole backdrop behind the glass with a damp towel. And we're going to dust and wipe down with a damp cloth and wipe down all these switches and all this junk before we go over it with the deoxit. We're going to clean all these controls with deoxit. We'll have the unit standing on end. We're going to clean all those controls with deoxit. And as the tubes go back in, we're going to clean the sockets and the tube pins with deoxit. Here's the multiplex board. This is the multiplex decoder. It's a separate board. There are 2 separate boards on these things. One is the multiplex, one is the front end. This is a separate front end board that's replaceable. You have trouble with the front end, you could replace the entire front end, the whole thing. Of course, you'd have to restring it, but anyway. So on the multiplex, there's this little pot on the side. This is your separation control. So it's a pot. So you want to make sure you spray that and rotate it and make sure that's clean. So when you're doing the alignment, you don't have all kinds of issues. We're going to talk about the tubes shortly, and what I wanted to say about that, these multiplex boards, when these units were assembled, these boards came in populated with 3 12AX7s. There's 3 12AX7s in this board. And it came already, and so therefore, you will not see the same type of 12AX7 in these boards as in the regular set. For instance, in this set, all the 12AX7s were Telefunkens. They were all Telefunkens. The ones that were in the multiplex were these guys with the yellow writing. Okay, and I believe these are made by some American company. I really don't know. I don't remember. But then certainly not Telefunkens. And all 3 of them had one section weak, whereas all the Telefunkens that were in the set were all still good as new. Trying to find one of them. And that's the yellow one. Let me show you what Telefunken. Here's a Telefunken. Here's one of the Telefunkens. So there's a total of 9 12AX7s if you include the multiplex board. So the ones that are not in the multiplex board were these guys, the smooth plate Telefunkens. Every one of them tested like just about like new, 95% like new. The output tubes, I don't understand this. This set looks like it had almost no use. Look at these tubes. They're like brand new. Not only are they physically like brand new, when I tested them, they literally pinned the meter. These things are hot like they just came out of the Fisher factory. They're like brand new. Normally, these units run so hot because they're not biased properly that you'll see the phenolic base around these things all burnt and crumbling. You can just pick it apart with your finger. This thing is brand new. All 4 of these things, they're like brand new. This is totally amazing. And of course, that's where they go back there. And these are the space expander jacks. I'm going to pull those out and clean that too. If you push these in too far, you will short out the channel. Always remember that. These are not to be pushed in. They go in like just enough to make contact, push them a little more, and that's it. If you ram them all the way in, you short out the channel. That's why a lot of the later ones in the solid state, you'll see a black tubing over this to prevent from pushing it in too far and shorting out the damn thing. Of course, these are the 3 topside filter capacitors, which when I fire it up, we're going to see what kind of shape they're in. These should never, ever be replaced unless they are bad. Fisher used an amazing filter capacitor. I don't know who made them for them, but they are just incredible. And just like anything else, I mean, you wouldn't change a transformer if it was good. So you don't change these either, because they're going to go on for years and years and years. The one we do change, because time is marching on now, it's going on 50 plus years for these things, is the bias capacitor, because bias is very, very delicate, very sensitive. You can cause a lot of damage, and it gets the roughest type of service. It's a high current, low voltage circuit, and that tends to wear a capacitor down, where these are high voltage, low current, and they last for a long, long time. But if we have to replace one, we'll go there if when the time comes, when we fire this thing up and check it. And we're going to check it. We'll show you how to check it with the scope, listening test, the whole 9 yards. These two pots are phase inverter adjusters. It adjusts half of the drive of the 12AX7. So you get a relatively equal drive on the output tubes. You put that on the scope and you adjust it. It's really not that critical. I mean, yeah, they work. Most of the time, for some reason, they all have to be turned like completely clockwise or something like that. For some reason, every one of them is the same. They got to be like completely clockwise to get a good balanced output on the output tubes. And I think that's about it for now until we turn this thing on the side and start cleaning. Of course, there's the signal meter and the stereo beacon indicator. Yeah, I guess that's about it. Oh, by the way, this is the later serial numbers. You got the new Vista front end. That's the two small sockets for the new Vistas. The earlier ones use a glass tube there. And the 6HR6, for some stupid reason, this 6HR6 is like $30, all kinds of stupid money for these things. You want to know the truth? Fisher was trying to accomplish a certain sensitivity level without adding an additional tube. So they used the 6HR6, was supposed to be a little bit higher gain. You could put a 6AU6 in there. I don't think you'll ever notice the difference. It'll work just as good. So if you don't want to go for the $30, even though the set's worth it, you could put a 6AU6 in there, and the set will be perfectly happy. And the rest of them, of course, are 6AU6s, except for the stereo beacon tube. This is the 6GK5. If this tube is bad, your stereo beacon will not turn off. You could pull the tube out, and the stereo beacon will go on, and that's it, won't turn off. So this actually controls the off of the stereo beacon, more so than the on. And if the tube is good and it doesn't turn off, you got a bad relay, which is not that uncommon. It does happen. Those relays do fail, and they're a pain in the neck to get. And, of course, I have them. All right, that's about it for now. We'll evaluate everything as we go forward. But this is the next step for this restoration. We're going to get the glass out, of course. This way we don't get I'm going to clean the glass. This way we don't get the oxide all over it. Okay. Okay, when it comes to the knobs, they are easily restored because the rings on these things, this little band is actually real brass. These are real solid brass. They usually look like hell when you get them off. This wasn't too bad. You got a new set of knob caps. You popped off the old knob cap. You can't polish the originals, because when you polish the originals, it removes the swirl. It just makes them look like brass hubcaps, and they just don't look the way they're supposed to look. They're supposed to have a certain type of a swirl and a sheen, which I'm going to unwrap these and show you the reproductions and see what I'm talking about. Okay, these are the reproduction knob caps, which are pretty nice considering. They're much thicker brass. They're solid brass, American made, and as you can see, they have that nice sheeny swirl to them, which is the way the originals were. And here's the one for the tuning knob. And we're going to put these on. Obviously, you orient them to the little pointer on the knob there. There's a little indexing mark. So you glue them in the right position. Obviously, the tuning knob doesn't matter. And this is the speaker selector, because it has the little ridge on it. And here's the tuning knob, smooth all around. And we use good old Elmer's glue. Elmer's glue, the best stuff for knob caps. Elmer's glue. A little couple of drops around the ring there. Stick the knob cap on and let them dry for a day or whatever, depending on the humidity. Okay, so we're going to get these going, and when it's all done, put them all on a piece of cardboard, and we're going to spray them with a clear lacquer. The whole knob. The caps already have a coat of lacquer on them. It'll be the second coat of lacquer for the knobs, the first coat for the knob caps, second coat for the knob caps, and the first coat for the knobs, and that's all they get is one coat. Okay, so we'll get these glued up, and I'll show you what I'm talking about. Okay, we have all these knob caps glued in place, almost glue, as I mentioned, and I want to get them dry, good and dry, because I'm going to lacquer them. I like to lacquer them in the daytime outside if I can, and it's a little late right now, so I'm just going to put them on my drying rack. And here is my drying rack. I have the rest of them up there already. Yeah, that's the Caig of my SA100 power amp, which of course is restored. This is my bench amp I use for testing. I sit them on the Caig. The amp is on. These knobs are made of bakelite. They will not melt. You can, in fact, if a knob cap is stuck and you can't get it off, you can use a heat gun, and you will not damage the, I mean, if you roast it to death, of course you will, but normally heat does not affect these knobs. They're made out of a very tough bakelite, and they are on the drying rack, and they will stay there with the amp on for several hours until they're good, and even an hour is fine, until they're good and dry. And then we'll cool them down, and tomorrow we'll put them on a piece of cardboard, take them outside, and give them a shot of some clear, fast drying clear coat. Okay, I'm at the point of removing the dial glass. Get some light over here. I pulled the 4 screws out, 2 on each side. Got the bulbs out, and this is very interesting. This foam is so rotted. Watch what's happening here. I'm going to pick this clip up. The whole damn thing is going to come off, which is really funny. It's not every day you see this. Usually it just crumbles. Did you look at that, huh? This is all a rotted foam. I'm going to put that aside to save those clips. Break this off. Throw this in the garbage. I'm going to get the clips off over there. And we're going to pop this off. Get these clips off. Sorry, I'm a little herky-jerky here. It's doing this one-handed. Okay, that clip is off. Now we'll see if the glass will come off willingly, which usually it does not. Oh, look at that. It's popping right off. Oh, lucky, lucky. I had the popsicle stick already. Okay, so there's your dial glass. I'll even show you what the part number is. The part number, you can barely see it. It's way down over there. Really can't make it out. Oh, there it is. That's backwards. Hold on. You always got to be careful with Fisher dial glasses that you get the part number correct. Yeah, 991-107, I think it is. It's hard to focus on this damn thing. Yeah, 991-107. The suffix don't mean beans. It's a 991-107. That was backwards. Come on, focus, you son of a gun. There it goes. Anyway, you get the idea. And we're going to clean this, like I said, damp paper towel, nothing else. All this black stuff is going to come off with a damp paper towel, nothing else. And be careful when you lay it down, you don't lay it down on the print. You lay it down the other side up. And we're going to clean back here with a damp rag, get everything nice and clean, and then we're going to start with the deoxit before we put the glass back. This way we make sure we don't splash anything with deoxit. One last thing, if you did have to use the popsicle stick, you always do it at the edge, at the corner. You never do it in the middle. And obviously you're going to break the glass. You do it on the end. You pry it off, and like I said, once that happens, you peel it back, it's going to pop right off. This one was a dream. It came right off. You very rarely see that. They're usually stuck like crazy. But the popsicle stick, and you just keep coaxing it. Keep yanking, yanking, yanking. That's why the popsicle stick has a little bit of flexibility. And you yank, yank, yank. Eventually she's going to pop loose. No heat, no nothing. Just a little bit gentle force. Okay, here is the dial glass after it's been cleaned. Obviously it's very shiny, so it's hard to, with the reflections and everything. You see my lights, you see my hands, you see everything. But anyway, get the message. Let's see if I tilt it up a little bit. Yeah, there we go. It is spotless. I got it laying on a felt. There's the part number. Dial glasses normally start with an N. That LX, I have no idea what it is. It makes no difference. 991-107. Nothing but water, paper towel. Sprayed a paper towel with water with a spray gun. Got it nice and damp. Actually, a little wet. And nothing but water. All that black gunk at the bottom from the old foam rubber all came off. Most of the junk on the sides came off, but that doesn't even matter because you're not going to see it. But as you can see how clean it came. There was all that gunk where the part number was. And generally speaking, the writing can be pretty durable, but you don't want to get too nuts. Now, holding the glass in, there's those 4 metal clips. These things are held in with screws. These here. Originally, they had these, I guess they used to be cork. These little things, the pads. These pads were glued on here. And that was the cushion when you tighten the screw down on the glass. So those are shot. They're all dried out. They're hard as a rock. You normally pop them off, throw them out, and you make new ones out of. You need a nice fluffy cardboard. I use mat board. This is a piece of mat board. You see it blue on one side and white on the other. That you use in framing, because I do framing too. So I have plenty of mat board around. And you make 4 of those. And once again, Elmer's glue, and just glue each one of them on the end of these. Let them dry, and those are going to be your new pads for when you screw down these clips to hold the glass in place. And that's about it for now, and then we'll go on to the next stage. Okay, here we have the tube complement for a 500C. This is the entire tube complement. You have your, these are the 9 12X7s, 3 of which are for the multiplex board. Tone control, 2 tone control left and right, preamp left and right, and of course your driver tubes left and right. Then we have the 6GK5, which is your stereo beacon control tube. We have your tuner lineup. This is the first tube in line, a 6HA5. Then comes that 6HR6 and your 3 6AU6s. You will never find a better 6AU6 like the original Fisher 6AU6. Now, we had to replace a few of these. Here is the original 6HA5. Anytime you see these, they don't necessarily have to be weak, but they're probably midlife. And if you're doing a restoration, you really should replace it. So this one was, it was above minimum, but it really wasn't like a really good, strong tube. So the new one, extremely strong. I use paint marker to mark these things. A lot of times the chalk writing comes off, and then you don't know what the hell the tube is unless it's etched, like this guy. See, this one's etched. Anyway, back to business here. Okay, so we replaced this tube with a fresh one, even though it was still good. And the same thing with the 6GK5. This is the original 6GK5. I mean, the minimum on a Hickok tester is like 2,500 micromos, and it tested at about 6,500, 5,000, which you think is good, but the new one tested at over 15,000. So it's not a case or a matter, is the tube going to work? Yeah, sure, the tube's going to work, but for how long is it going to work? And if you're doing a restoration, you want this thing to last for years and years without needing attention, especially something as preventable as a weak tube. So that's one reason we replace tubes that are just not really, really strong. And here's those 3 that originally came in the multiplex board that I mentioned, how the multiplex board came populated with tubes at the factory. And as you can see, it's a different and it's an American-made 12AX7, as you can see there. And all three of these have one section tests good, the other section is weak. So it's not uncommon. For 12AX7s, Fisher 12, American Fisher 12AX7s with the yellow writing, very, very common to find them weak. The Telefunkens, which these are, as you can see, these are the smooth plate jobs. These are the famous smooth plate Telefunkens. You can see those plates in there have no grooves in them, no lines, no nothing. They're smooth. This is known as the 100,000 hour tube. This tube goes and goes and goes, quiet as can be. It's a wonderful tube, and that's what Fisher used. And you say, oh, well, they used good stuff back then. Well, you know something? Back then, in the early 60s, these tubes were considered inferior to American tubes, as funny as that sounds. That's really not the case. They're pretty damn good tubes. All right, so that's your tube lineup for the 500C. 9 12AX7s, 6 GK5, 3 6AU6s, 6 HR6, 6 HA5. This, oh, by the way, that's another reason you want to make sure this is a good hot tube. This is your RF amp. Oh, wait a minute, we forgot the two Navistas. There's Navistas, yeah, the two Navistas. These go in the front end also, of course. There's two Navistas. Those were also marginal, and I had original Fisher ones that test, you know, firecracker hot. These things should, micromos on the Hickok, they should test, you know, 9,000 or better. Forget about what the minimum is. That's what they should test. So, yes, I almost forgot. The two Navista tubes. So you got the two Navistas, the 6HA5, 6HR6, 6AU6s. That's your tuner lineup. And from there you go to the multiplex, and of course your audio, and here's of course your output tubes. And I mentioned these, how they're like brand new. These things, they just test amazing. Just about 13,000 micromos each, which is really, really amazing. That's pretty good for a 7591 of this age, unless it's NOS. And even then, you got to watch. They're very prone to shorts. That's why these things are just, they're great tubes, but they are so prone to shorts, the way they're designed. Even brand new ones. You buy a brand new one, you know, good old eBay, you buy a brand new 7591 on eBay and put it in your tester, and you say, oh my God, you know, one section's shorted. Anyway, we're going to get these tubes in the set, clean the sockets, always spray the pins, even though I sprayed them before I tested them. We're going to hit them again before they go in the socket. And with the deoxit. Deoxit is your friend. Remember that. When it comes to this stuff, there's nothing like good old deoxit. It's the best there is for this electronic stuff. We're going to clean the pots. We're going to do all the pots before we do anything. Okay. All right, we'll come over here to our tube testing station. And we have our Hickok 539C. And we also use a TV7DU, which I purchased years ago. Thing is in mint condition. It was last restored and calibrated in the 80s. And of course it was checked many times after that. Anyway, 12AX7s, I have been testing them in this one and doing the output tubes in the Hickok. And always when you check a tube, you go through and you tap through each range. And you look at your tube tester, read your manual, it tells you how to do it. And you don't want to see this shorts light flash. Where it is, over here, this is the fuse, that's the shorts light. You don't want to see that flash, and you don't want to see the meter jump when you're going through the ranges. And then when you hit your test button, this one has either momentary or a lock. And then you'll get your, these are really, really good tubes. They pin the damn meter. That's how good they are. It's amazing since they're original Fisher tubes. There's one right here. Yeah, with a nice bakelite base. They've never been overheated. Really unbelievable. This is a set of tubes that you don't see very often. They're mint condition, they're original, and they have not been stressed out. And in here we check the 12AX7s. tap on it like that. I already did these. I'm just going through this to show you. Here's the shorts light. You know, go through all the ranges, tap through each range, put it in the test range, hit your test button, and we get a nice healthy reading. But we're going to do this, obviously, to the whole set of tubes for this 500C. And so far I only went through maybe not even a quarter of the tubes. I only found one 12AX7 that has a half a section weak, so I'm going to be replacing that, of course, and whatever other weak tubes we come up with. All right, that's it for now. All right, here we are at the back of the unit. I gave it a good cleaning with a damp rag. Rubbed out these transformers a little bit, got a little bit of the rust off of them. And the back of these, the back of this set, all these screws have to be backed out. Some of these things, believe it or not, weren't touched since this thing was new, and you got to actually get a good screwdriver, and actually you'll hear it crack, because these are all oxidized. These chassis were plated, all sorts of parts, the screw, everything, were plated with this cadmium stuff that was supposed to prevent rust, but the cadmium ages, and actually at this point, it gets powdery, it could be toxic, you got to be careful with it. The best thing to clean that with, if you have like a really, really bad one, completely coated with this horrible powder type of stuff, that's the oxidized cadmium. Good thing for that is just white vinegar. White vinegar, and wring it out in a rag, and go over the whole thing, and then go over it with a damp rag, like as a rinse, and it'll be clean like no. Anyway, like I said, some of these screws had never been loosened. Got to pop them all. These are your speaker impedance wires. Sometimes I replace them. These are in really good shape. I'm just probably going to leave them. And when we spray the deoxit from the inside, with all these screws are backed out a little bit, about halfway out. When we spray the deoxit from the inside, it's going to come through all these screw threads. And there's a piece of paper towel on there. It's going to come through all these screw heads and clean them. Once the deoxit hits that white stuff, it just kind of like dissolves it away. Here's all your inputs. You take a banana plug, not a banana plug, like an RCA plug. You spray all around here, and you take the plug and go in and out, clean it. Spray the plug, and that's it for the back of this thing here. And of course, we're going to pop these out and clean inside those holes and make sure that's good and clean. The fuse, the fuse is out. Always check the fuse. I've seen 20 amp fuses, 30 amp fuses. You'd be amazed. This still has the original 3.2 amp. I used to change them to 1.5, 2 amps. It's fine. The original fuse is fine. 3.2 amps is what the original was. It says it right on there. And that is what is in the fuse holder. But you hit that with a little bit of deoxit also before you put it back in. Any place there's an electrical connection, deoxit. Okay. All right, this whole corner here is the bias supply. All this, we're going to rip all this stuff out, remove that capacitor, remove the clip, cut all this junk out, and we're going to replace it with 2 individual capacitors. We're going to have to solder in some new terminal strips using the large soldering iron, which we'll show you in a minute. It's a huge 100-watt massive soldering iron, which you need the mass in order to solder to a chassis like that, because otherwise it just saps the heat away from a normal iron. All right, we'll gut it out and show you what it looks like when I'm done. All right, as we prepare to do the bias supply, we have everything cleaned out here. We're going to do a little more. These resistors are going to get changed, and these capacitors are going to get changed, and we're going to clean and dress all these wires. We're going to strip them, tin them all up, get everything ready. And here is a schematic of what we're going to build. Those lines are, of course, are these fluorescent lights, or is it this LED light? No, it's the fluorescent lights. Anyway, there's a schematic of what we're going to build. We're going to put a brand new 15 ohm resistor. Here are our 2 2200 microfarad capacitors, minimum 35 volts, and our bias rectifier. So here are the parts we have lined up. The 2 terminal strips that we're going to mount. These are going to get soldered to the chassis. one there, and one around here, and the capacitors are going to go this way. These are very high quality Sprague capacitors. These are American made Spragues. Probably can't even get them anymore. I have these in my stock. And a brand new 5-watt resistor. That's the that's this 15-ohm resistor here. Of course, the schematic is in the the schematic is in the service manual, but not the way I drew it here. This is done with the new replacement parts, basically replacing the large filter cap that we pulled out of there with the mustard colored cardboard. All right, so we're gonna rough up the chassis here, rough it up here. I'm gonna get the big soldering iron out, which we'll show you when we get that ready to go. Okay, this is the iron we're gonna use. This is an American Beauty, 100 watts. And I'll just lay it down here. It's a 100-watt iron, but you notice, massive. When you solder to a chassis like this, you need a massive iron. Remember, heat flows like water, and you need a reservoir of heat, because the minute this thing touches the chassis, it's going to sap the heat away. It's going to be a giant heat sink. You know, there's the transformers under there. There's a lot of stuff to absorb the heat, but you want it to get hot fast, and you want it to get hot enough to take the solder. Remember, we're going to clean this. We're going to buff it up a little bit to shine it down to the bare metal, get all this oxidation off, so it's nice shiny clean metal. And these irons take a long time to heat up, a good 10-15 minutes. They'll be really, really nice and hot. We'll tin up the tip, and we're going to get some solder on there to take forever to heat up and forever to cool down. But this is what you need to do soldering to a chassis. Okay, I already have a small blob of solder on there. The iron really wasn't hot enough. It has to be really, really hot. It's got to sit. Like I said, 10-15 minutes. This thing's got to really develop heat. So we'll show you how this acts now that it's really hot. And you can actually hear it humming a little there, because it doesn't know the words. All right, see now that she's good and hot. See how nice she formed a nice puddle. I'm going to put one over here. There we go. And 2 nice puddles of solder. We're going to add this piece. Yeah, see, when she's good and hot, she really flows. Okay. In the meantime, before we even started that, we prepared these. We got these all tinned up. Get this wire out of the way. We got these things tinned up. Let's see, that's tinned. And to install these, we'll get this nice big hot iron. We'll put a little bit of solder on the tip. And we sit this like this. And we put this like this. And we'll let the heat do the work. Just let it sit. You'll feel it fall right into place. It'll collapse right down into the chassis, into that puddle. And there you have it. Not only is it well secured, that's as hot as the son of a gun, but now you actually have an extra, you have a good ground lug there too. And now we're going to put the other one in the same way. All right, now we're going to get this one in. That's it. Wow, nice beautiful puddle. That hardens just about instantly. Alright, and that is basically all you are going to need that big 100-watt iron for. So I am now going to unplug it And it's going to take probably 20 minutes to cool off. The darn thing is so big and massive. Of course, we took measurements before we did this, and I've done it 100 times, so it's not like the first time I did it, but you always obviously make sure you have clearance for your capacitors. See, they're going to fit in there nice and snug. These are very, very large capacitors. Yeah, so we got just enough room in there. They're going to fit perfect. Everything's going to be hunky-dory, and now we're going to continue with the wiring. All right, so the bias supply is done. Here's the two capacitors, 2200 microfarads each. Here's where one of them goes to the positive of the bridge. Here's the other one that's grounded. This is actually the leg of the capacitor I put through. You really didn't need that insulation, but it looks nice. The new 15 ohm resistor. The red wires are the AC from the transformer for the rectifier. This is the positive, and that green one, which is the white wire, is the supply that goes to the capacitors, which have the negatives connected together. And here's the feed resistor, and here's the shunting resistor. And that's about that for the bias supply. That's all done. And of course, over here is the where she feeds. Where is it? Right over here, this white wire. There we go, down here, this white wire. That's your bias supply. It goes to the output tubes. This is just a little capacitor, kills noise, 0.01 microfarads, and that's an input, an inrush current limiter right here. Thermistor, inrush current limiter. So when you turn it on, turn the set on, the voltage actually ramps up very rapidly. It's a second or less. And that actually saves the power switch and some other things. The components you don't have that blast when you turn the juice on. And that's about it for the bias supply. Everything else is done. We have all the capacitors have been changed, and that's about it for now. All right, we did the cleaning of the pots and controls. Good old deoxit. Stick the straw right inside in there and in there, and blast it, turn the control, do them all down the line. You could put a little drop in here sometimes, get it in the bushing, turn it back and forth, that'll loosen it up. Of course, the slide switches, you spray up in there where the contacts are, back and forth, nice Q-tip in the headphone jack hole. Your selector switch here, it's got like 5 leaves. This thing is like an octopus. It's got a lot of, look at this really good. Sometimes these contacts are jet black, and you take a little Q-tip, one of those cotton swabs, soak it in deoxit and just go clean it up, come off like magic. And I keep a paper towel crumpled under the volume control to keep it on end. Power transformer down, and this takes all the excess, because it's going to run down, and that's not a problem, because as you're spraying from up here, it's going to drip, and I mean, you don't go nuts, but you know, some of it's going to get down there. This will catch any excess, and you just pull it out and throw it out. Now we're going to flip it around. Got to clean this. Going to blast it from in there. As you can see, they're upside down for cleaning, and you rotate it while you're cleaning it. So we've got to clean those two things while we have it flipped over. And the relay. Here's the relay. You got to be very careful with these relays. You don't want to mess with the contacts. So what you do is you take a very thin strip of paper, stick it in between the contacts, put a little bit of pressure on the contact, and just pull the strip of paper through with the deoxit on it. You wet the paper with deoxit and do it on both sides of the contact. And you lift it a little bit. You could use like a dental pick or something. Just put a little bit of pressure on it and just pull the paper through, and you'll see I'm going to show you when I do it. The paper's going to be all black. We cleaned the inside. I put the oxide on all of the threads on the inside of any of these screw things. We're going to do the outside too because they're really dirty. So I'm going to turn it around and I'm going to put some deoxit on the screw heads on the outside. It gets rid of all of that oxidation and lubricates them and gives you excellent electrical connection. Of course, all the soldering is done. This is the mono de-emphasis resistor we changed to get the correct de-emphasis. And the stereo is the multiplex board right here, this thing. And there's one of the channels where we changed the de-emphasis, and the other one is under there. Right there, this resistor right here. You can't see it, it's kind of, yeah, right down in there, it's kind of dark. Anyway, that's the next stage. And now we're going to turn it around and do those two pots. The back, connect the speaker impedance leads. Of course, when we do this cleaning, you get the glass out. You still got to wipe the front down over here. Let's get some light. We're going to wipe this whole panel down. And you keep the glass out just in case a little bit of deoxit gets on the glass. It's the last thing you need. We're going to put new lamps in. Original, new old stock dial lamps. Okay. Okay, this is cleaning the relay. I actually already did it, and I'm just going to show you what I was talking about. Here's a piece of paper soaked in deoxit. You take something like a dental pick, and you put a little pressure on it, and you pull the paper through. Here we go. You pull the paper through, and you'll actually see some dirt on there, some black, and that's it. You don't want anything abrasive, and be careful you don't bend the contacts. They should be set so that you could barely hear them if you hear it at all. If you hear this loud clicking, it's probably not adjusted right. I mean, it works the same, so it doesn't even matter. You're better off just not messing with it. And we did all the things in the back, all the controls. Not the controls, the jacks and screw terminals, and I always use this thing. It's just a cut off RCA plug. Soak it in deoxit and stick it in all the holes, turn it around, spray inside all the holes. Deoxit is great stuff. It doesn't hurt anything, and you can use it with reckless abandon. All it does is clean. And yeah, that's about it. I don't know if I mentioned this before. I hate repeating myself, but better safe than sorry. There's the inrush current limiter. Very interesting device. It will greatly increase the life of your power switch and other components. A lot of companies used them right off the bat. Fisher didn't, but companies like Macintosh in the 60s would use one of these, especially on the big power amps. This is the inside of the front end compartment. I normally mark everything when I restore something. This is, I've done over, I've done about, I don't know, 600, 700 of these things. So, anyway, don't ever touch anything in here unless you really know what the heck you're doing. Because even moving a capacitor, and just moving it, will detune the front end. You can knock off dial calibration. You can knock off, you could screw up the selectivity if you mess with one of these coils. You do not want to touch anything in this box. I just took the top off because, took the cover off because, like I said, I marked them. And just to take a look inside, make sure everything is good. These are your 3 capacitors. These are tunable capacitors, adjustable capacitors, variable capacitors, whatever you want to call it. It's got a little like a screw slot. That's part of your alignment procedure. And these things with the slugs in them, this is the low end of the dial, this is the high end of the dial. You got the 3 of them. One of them is actually the dial calibration, the other 2 are for sensitivity. And to calibrate the dial, sometimes you have to go back and forth. You set one, you go back, this one's off a little bit. You set that, and this one's off a little bit. Eventually they converge. And then you go on to the other 2. The sensitivity ones. Anyway, that's the inside of this box. And again, you don't touch anything in here. Yes, you can see some of these. Sometimes you look in these things, you'll actually see capacitors are glued in place. Yeah, that's not by accident. They glued them in place because they don't want them moved. These things are called feed-through capacitors. It feeds through the wall of the front end. They're actually soldered in. It looks like a little disc with a rod through it. That's actually a capacitor. And there's one here. These are not, they're feed-through capacitors, but they're in the phenolic. This one is actually removable. There's this one right over here. You can actually unsolder that and replace it if you needed to. There's a couple of more of them over here, feed-through capacitors. Okay, now we're going to turn it around, and the other side of this front end is where the tuning capacitor is. There we're going to do a little bit of some delicate cleaning and lubrication. Okay, what I'm going to show you now is very important, very critical. Well, very critical, but it's important. This is we just removed this cover, just popped those little tabs off. And here's your tuning capacitor. And here's what we're going to do. First of all, we're going to lubricate the entire linkage. You can see you got all these pulleys all the way down the line. And then this is, I don't know, to me this is like common sense. You go down here, especially with this cover off, you can access this other pulley down there. You want to lubricate all these pulleys without trying not to get any of it on the dowel cord. Back of the flywheel, where the flywheel passes through the face panel, we're going to put some oil in here. But when it comes to this tuning capacitor, we're going to use this stuff. This is deoxit, 100% solution. This bottle is it's only about an ounce. It's close to 30 bucks for this bottle, but it's the best stuff in the world for this purpose. Each gang of this tuning capacitor has a brass contact. I'm going to see if I can focus in on this thing. This thing is not focusing well. Let's see, hold on. Okay, I zoomed it in a little. Let's see if I can get in there. Right over here, you see this brass leaf against this other brass piece here. That's a contact. That's like a little finger right here. Another one, and here's the third one. And we got to get just a drop of deoxit of this super stuff here. Where is it again? Here, this stuff right here. It's 100% solution. Just one, maybe 2 drops. Right. I got to get in there again and point right on these things here. See this little contact, and as the capacitor turns, this is your electrical contact right here. Now, if that's dirty, when you tune back and forth like this here, you'll hear scratchy sound. Okay? So we'll bring it all the way to the end, and we're gonna lubricate those points. Well, it's lubricating and cleaning them, mostly electrically cleaning them. Over here, you want to put oil. Right in here. You're going to put a few drops of oil in there. You're going to get a drop of oil on right over here where the gear is. Nothing on the gear, just over here. Don't ever get anything on these plates. Don't ever get anything on these plates. Then you have to flush them with something like Freon or something like that. That's why I say only 1 drop of this deoxit on each one of these contacts. Okay, I oiled the whole mechanism. This is what I use for that also. This is Caig. It's a precision instrument oil. It's got silicone. It's beautiful stuff. Also made by Caig Labs, who makes the oxit. All right, I put a drop over here, this end. I told you about this side. This part right here, you oil it up, it'll soak right in, and take a cotton swab and you can clean all the gunk off, all the dust and the stuff and all that other junk. On the flywheel, over here in the back of the flywheel, where's the flywheel? Here's the flywheel. There's this, get a stick. There's this little vinyl plastic thing. It's supposed to be, the brass is supposed to spin inside of this. It was so dirty and gunked up that this was actually spinning inside, which is no good. So drop of oil here, drop of oil in there, hold this while you turn it, and now it spins beautiful. Everything is nice. And you also have the one in the front here. There's a vinyl, a white vinyl in there. If that's not well lubricated properly, that'll be turning too, instead of the shaft turning within it. And that's it. And the dowel point is moving nice. And everything is nice. Everything is clean and oiled, and boy, she's moving beautiful. It was all stiff before. Now everything's freed up. So now we're going to put the cover back on, go to the next step. Alright, we got the dial glass back in. There's the clips with the new cushions on them, the pieces of mat board. On all 4 of them, I glued them on. Put them on my SA100 drying rack, and got them nice and dry. And, I usually use one of these things. It's the screw-holding screwdriver to get those clips back on. And remember, we're not going to put any foam on this. We're going to put it on the back of the face panel. And incidentally, when you put the glass in, if there's any back and forth play, you always seat it to the left. And of course, with the dial all the way to the left, you should sit exactly on 0, just like this one is. And if it isn't, you have this dial pointer is often glued to the string. You're going to have to break it loose and slide it to the proper spot. And either just leave it like that or put a drop of like Elmer's glue or something to hold it to the dial cord. But normally they're pretty close, and like this one, it should be right on the button. But like I said, if there's any play putting the dial glass in, it's always to the left. You seat it to the left, and you don't go, ape crazy tightening these things. I mean, you make them tight, but you don't really want to. You're pressing it against the rubber. Anyway, here's the face panel, and we're going to do this next. It's got some soiling on it here and there, not that bad. Best thing to do with these is in the sink with ammonia. Yep, straight ammonia, pour ammonia all over the darn thing. I'm getting a little bit, some lines in this video because of these lights. One of them is an LED. I don't know what's causing these lines. Anyway, we're going to see probably all of this stuff is going to, anything organic comes right off, and the ammonia will not harm the writing on the face panel. It will not. See around the selector, all this gooky stuff, that's all going to come off. Sometimes you see around the volume control, I mean, black as coal. I don't know what these people are doing, that they got to turn it like a gorilla. You grab the knob, you turn it like, you know what I'm saying? But not everybody does that, and then you get all this black crap around there. Ammonia takes it right off. I'm going to get this washed, and we're going to go to the foam rubber backing next. Okay, this is what we do to the back of the face panel to get that foam seal back. I use this weather stripping. You can buy this at Home Depot, Lowe's, 3/8 by 3/16. It's adhesive. You peel the stuff off the back, stick it on. It's always going to stretch a little longer. And you take your razor blade and you trim it. See, I left this one. I didn't trim this one yet, just to show you. But you could just take this blade, just go like that. And pull the piece right off. And there you have your perfect seam. And it sticks really well. And will last a long time. And that prevents dirt and stuff from falling down into these switches. And it prevents the light from bleeding this way from the light bulbs. And yeah, that's about it. And the panel's all clean, obviously. And as you can see, put this under the light here. All that gunk is gone. All the marks are gone. It's like spectacular clean. Really, really nice. The ammonia did a good job. This panel is like immaculate. It's perfect. Which you would have never thought before. Alright, we're going to get the panel installed. When you put the panel on, you never ever, or off, take it off, you never ever use anything other than a hex driver. You try using pliers, you're going to scratch the panel. You always use this, what is this, a 1/2 inch, I believe. Yeah, it's a 1/2 inch, yeah, 1/2 inch hex driver for the 1/2 inch nuts that hold it on. All right, so we got it all back together. I don't have the knobs on yet because they still have to be sprayed. So temporary knobs, really the three main ones we need just to make things easy. The tuning knob, volume control, and selector switch. Make sure all your switches are down. And she's ready to power up. I got all the tubes in. Tube shields back on, very important. Keep the tube shields on. You got the two for your phono and two for the tuner. New light bulbs, number 47s for the stereo beacon and the meter illumination. Output tubes are in. Have speakers hooked up, and we're connected to a variac that's in that corner back there. This bench is a mess. Got a lot of stuff on this bench. Anyway, so she's just about ready to fire up. So we're going to bring that variac up. As you raise the variac, you just keep an eye on these things. Make sure they don't start getting hot. This one's a little tough because it's in a cardboard. This one's bad. You'll normally see, you got to check this with the scope. We're going to look at it with the scope. You'll normally see a huge spike on the scope. You set the scope to 2 volts per centimeter. If you see like the whole screen or larger than the screen when you're on this one, that's not a good sign. It should only be a few centimeters. These you should see as little as possible as far as ripple. We're talking about ripple here. And that's about it. This is a later unit, as I mentioned, because it has the Navista's front end. I got the Navistas in there, as you can see. These are two hot ones. These test over 9,500 micromos each. New 6HA5. These are the IF transformers. This is your first stage, you know, and so on and so on. This is your detector. There's a little special way you got to align that thing. This is the multiplex board. All right, well, here's the completed unit. It is completely finished. There are the restored knobs with my reproduction knob caps. Everything turned out just incredibly perfect. Everything's beautiful. Did the total alignment, tuner alignment, multiplex alignment, aligned the phase inverters. So she is rocking, ready to go. I'm going to slide it back in its cabinet. And we'll have a happy customer pick this up. Actually, she's picking this up tomorrow. It's a customer's unit. Going to be pleased to see this video, I'm sure. As we talked about earlier, and I don't like repeating myself, but sometimes it's interesting to send certain points through. For instance, these multiplex subchassis. Got the multiplex subchassis and the tuner subchassis. This thing often came, as I said before, already populated with 3 tubes. And they have yellow writing. Anytime you see a Fisher 12X7 with yellow writing on it, made in USA, I don't know who made them. They're just not as good as the Telefunkens by no means. All 3 of those tubes had one weak section. One section was good, one section was weak, go figure. All the Telefunken tubes were perfect. Every single one of them tested like new. The 6GK5 was okay. We put a new one in. I want this thing to have, you know, service free for a long time. The 6HA5, the same thing. It was okay. The two 6CW4s, all 3 of the tuner tubes are brand new in there. 6HR6 was still good. And that's about it. So this thing is done deal. And we're going to mark all these controls like this thing. I'm going to get a paint marker and just put a little line on there just in case someone should move it by accident. You can just get it back to an approximation. Same thing with these things. Just I put a little mark on them just in case they get moved. This is really a silly place they put this. I mean, you hold the unit sideways, and you know you can actually damage that if you're not careful. That's the separation control for your multiplex. When you have it on the scope, that's your last alignment. First thing you do is your 19 kc, which is this. Then you do your 38 kc, which is this. And then you do your final separation control. And if you ever have trouble with one of these boards and you can't figure it out, or you can't get a part, just go on eBay and buy a board. Just change the whole board. It's only like 6, 7 wires, 2 screws, one there, one here. It's not hard at all. Don't let this stuff intimidate you. It's really not that hard. Same thing with this front end. It really isn't hard. Nothing in these things is hard. Drive you nuts a little bit sometimes, but it's not hard. Okay. All right. The tuner is, of course, excellent, but no location here, you could forget it. You could barely get anything. You could forget about trying to get that stereo light to go on. The reception here is just awful. Plus, I'm down the basement. It's just awful. But when you hook this thing up to the generator, it is like super sensitive. It is remarkably sensitive in the stereo regard. The slightest presence of a pilot signal and the stereo beacon goes on. So it's like really got a good multiplex board in there. Everything is like just perfect. And I guess that's it. Any questions about this, feel free to email or through the website, fisherdoc.com. If you want to do your own rebuild, I have kits. And if you just want to go get your own stuff and figure it out yourself, I'd be happy to supply a parts list for you. We got service manuals. I have everything. Here's the service manual for this thing. And here it is. They go by serial number too, depending on the serial number. I think this is the latest one. Anyway, that's the deal. I hope you enjoyed this. I hope you learned something. Any questions, pop them in the comments and I'll try to get an answer for you. But when it comes to these things, like I said, I've done over 500-600 of these things. So there's very little I don't know about them. Okay, as you may know, the 800C is just about identical to the 500C. The only difference is obviously it has AM and 2 extra tubes to support the AM. But here's an 800C glass that I'm cleaning because we have an 800C that's all finished up. We're going to get that out the door soon here. And I should have showed you when it was still dirty, but this whole bottom part here had all that black gunk from the foam, the rotted foam. And that stuff is water soluble. Now see, I got it face up, so the print is underneath. You don't want to damage that. And you get a paper towel, nice and damp. Nice, you can even get it, wet for that matter. Just not dripping wet, just wet. And just keep rubbing it, and let a little bit of water sit on all that black stuff. And eventually it'll dissolve and come right off. Anything stubborn, remember you're on the outside here. The outside of the glass has all kinds of filth on it. People spit on it and all this sort of garbage. You could use a razor blade and just, clean it up. Just make sure you don't use a razor blade on the other side or you'll have some surprises. The other side, the print side, usually all that's behind that side is atmospheric film. Who knows what it could be, cigarette smoke, whatever. And it's very easily removable. When you go to the other side and you clean the print side, you be very careful. Again, a nice, pretty damp. It's got to be not sopping wet, but it's got to have some moisture in it. It's got to be wet. And just rub it a few times, back and forth, all that stuff, and then quickly get a dry one and go back and forth with the dry one, and you buff it. I can't overemphasize that, because there's really nothing that quote-unquote dirty on the print side. And even when it's dry, you buff it up like this, and it'll look absolutely gorgeous. Never, ever wash one of these glasses under the sink. And I mean, in the early days, I didn't know any better. I used to do this, and next thing I know, I saw numbers floating around in the sink. So it's not a good idea. Fortunately, I've always had spare parts and spare glasses and everything, and I got spare glasses. So but you don't want to damage them. These things are precious. The part number, for some reason, is not on here. I don't know why it's supposed to be over here. I don't remember what the part number is, but it's similar to the 500C. It's got a different suffix. And of course you got your AM and FM. I'm going to show you the chassis of the 800C when I get it back up here on the bench now that the glass is clean. We're going to take the face panel up to the sink, give it the ammonia, wash it up, clean it up, come down here, show you the receiver. This is the underside of an 800C. This one's been rebuilt, of course. You can see everything's been changed. By supply, etc., etc. This is the area where the space is occupied by the AM circuitry. This is your usual phono tube, and in a 500C this would all be vacant space right here. But we have the 6BE6 and the 6BA6, your coils, AM coils. There's also a little diode over here. That's a very special germanium diode used in a lot of fisher equipment. Same one is used in the multiplex boards. In fact, they're in this multiplex board. Focus in down there. Where are they? They're on this side. If I can get a light in there. Yeah, you can barely see them. They're over here. That's the diode matrix on the multiplex. So this is an 800C. Like I says, identical. With the just about identical. I mean, it's identical. Just little issues in the chassis because you have the AM antenna bracket and so on and so forth. But this is your space that's again occupied by the AM circuitry. Everything else is the same. All right. In order to get this front end cover off, but you got to clean those brushes on the tuning capacitor. You got to take this bottom cover off. This thing right here, it's got to come off. And remember, you can't move anything in here, but right over here there's a nut and a washer. I took them off already. All right, and you got to get that off without moving anything. And if you do move anything, make sure you put it back exactly where it was. Now we'll flip this thing over. All right, once you got that out, there's these two here that you just have to loosen. You don't remove them, you just loosen them. Get something like a small little wrench or something. I keep this little 1/4 inch wrench around for this purpose. And you slide the cover off. And in here, you're going to see the very same brushes that need to be cleaned. Let me get a better position here. Okay, hopefully we could see this. Glare. This one here is one of the brushes. You got to get down right at the shaft where the brass leaf rubs against the shaft. There's one on this side. There's over here. One on this side. One on this side. There's one over here. And you want to get that deoxide stuff. This here. And we're going to put a drop on each one of those places where the brush contacts the shaft. Just a drop. Maybe 2 drops, depends. But never more. All this other stuff is going to get lubricated with the whole mechanism, all the pulleys, and not getting it on the string, of course. This thing over here, going to lubricate all this with regular that silicone oil. The K-lube, where is it? I'll show it to you again. This stuff. Of course, you could use any oil, but that's a really good stuff with the silicone. And before we do this, blow it out with a little air. I mean, there's cover on it, but you never know. Never ever blow it after you lubricate it. You stand the chain, you'll blow microscopic drops of that stuff everywhere, and if you get it on those plates, then you're going to have to flush it with Freon or something to get them clean. And re-oil everything. It's going to be a mess. These screws, by the way, are the AM tuning screws. That's what you do, the AM alignment with the dial calibration and sensitivity, and the other 2, 3 are underneath. Okay. Okay, here's the finished 800C. The best way to mount the AM antenna is with these wire ties. Nice thin wire ties. This way anything hits it, they'll break before the antenna does. And this is it. You'll never operate one of these without feet or in its proper cabinet so it gets ventilation. And never ever put a fan on one of these things. The natural cooling is plenty, and all the fan does is make dirt build up in the circuit. So there you are, all done. Beautifully restored 800C. Okay, now we're going to show you a classic example of gross incompetence. This is why people who have no idea what the heck they're doing with tube equipment should stay far, far, far away. I'm going to show you something here. This is an 800C. I was having some pretty substantial problems with sensitivities, driving me nuts. Because usually I go over it before I get the alignment generators going, and just to get a feel for what's up with the tuner. It's not, make sure all the cores are free, all the adjustments are free, everything's frozen, blah, blah. I go to hook up the generator, and right over here, you will see this little wire. It's a little bent over at the end, and it's got a sleeve on it, a piece of spaghetti. Okay? This is where you attach your alignment generator. This is called a gimmick. It's on the schematics, and this is where you attach your generator when you're adjusting the 10.7 megahertz of the IF stage. Some meatball took this, and because he says, "Oh wow, this is a," I'm going to turn it so you can see. This is a wire standing out in the middle of nowhere. Let's solder it to the chassis. And the goofball soldered the damn thing to the chassis, basically grounding out the RF. Isn't that brilliant? This is the degree of stupidity, ignorance, dumbness. I can't think of enough adjectives. The stupidity. People should not be touching this stuff, and this is the kind of garbage you find in tube equipment. These are all these brainiacs that are out there that think they know everything. Let me tell you something. This tube equipment is very special. It's not difficult, but there's tons of meatballs out there that don't know what end of a soldering iron to hold. And this is the end result. You find garbage like this. The minute I took this thing off the chassis, man, this thing sprung to life. It's so damn sensitive, it's picking up stations without an antenna. I just cannot believe that this kind of stupidity exists. These are all these gurus that are going to tell you can hear difference in capacitors, you can hear differences in tubes. They're a bunch of morons. A total bunch of damn morons. Keep your damn hands out of this stuff unless you know what you're doing. And the guys that know what they're doing are becoming fewer and fewer and fewer. These quote-unquote old-timers, yeah, they call me an old-timer now because I know the stuff for the past 40 years. Keep your damn hands out of this stuff if you don't know it really, really, really well. And most people don't have a damn clue. Here's a classic example of gross incompetence with tube equipment. Have a nice day. Okay, now for the purpose of illustration, I have an 800C front end that I pulled from stock. This is the whole entire front end unit. It might even be a new old stock one, I'm not even sure. No, it's a used one. Anyway, this is the gimmick where you do your tuner alignment. Now, this has a sleeve on it, this little sleeve of spaghetti. When you do your alignments, you clamp the lead from the generator onto this thusly. And that sleeve of spaghetti, as it's called, creates a capacitive coupling between the generator and the input to the tuner IF stages. And that's where you inject your signal to do the alignment of the IF, not the front end, the IF, which is, of course, all your IF transformers all the way up to the detector. I got the unit sitting here. In fact, it's turned on. I'm warming it up to do the AM alignment. Anyway, that is what this is for. It is called a gimmick, as I said. It is not to be fooled with other than for your alignment. You don't solder it to anything. You don't touch it. You leave it alone. You can see this No marks where it was soldered. It's not supposed to be soldered. It's a freestanding wire for alignment purposes. As I says, the one in the set, which you can see there, some knucklehead, looked like he blowtorched it to the side of the set. All that dirt and filth is all old solder. So, which we cleaned as good as I can, and I got that wire off there anyway. So that's what the story is with the gimmick. Okay, here I just printed this out. This is the alignment page for the FM 1000, just to give you an example. Now here is they're a little more detailed because it's a broadcast monitor and all that stuff. Anyway, here's a picture of the front end, the drawing of the front end, all the adjustments. Notice what you have over here. See a little wire sticking out? It says test point. Interesting, right? Now we move up to the alignment procedure. And, oh, lo and behold, look what we have here. FM generator connected to test point 1 through wire gimmick. That's that little piece of wire you see in there with the spaghetti sleeve over it. You notice it says less than 0.5 picofarads. That's the capacitive coupling that is created by clipping to the sleeve, not the wire. You do not connect to the bare wire, you connect to the sleeve. And that forms a capacitive coupling. Right there. Clip to the sleeve, not to the wire. And that is how you do your IF alignment. Notice 10.7. 10.7. You're going to generate 10.7. Okay, so I hope we learned something here today. So all these people trying to learn this stuff, it's wonderful to try to learn. You got to learn. You got to do things in order to learn. But don't do stupid stuff like this. Soldering the damn thing to ground, killing the tuner. All right? Have a good one.